welcome back. Did you bring devices? Yes, very good. All right, we'll play with them in a few minutes. I want to walk through a few more of these survey design how-tos in the first part of class today. And we're going to play with one or two data sets. And the second part, hands-on, you're going to be programming stuff in R and looking at factor analysis results and whatnot. It's going to be great fun. Okay. So let me get right into it. I guess to remind you, since it's been a while, a few key ideas from Thursday. One was this idea of different kinds of types of errors that can creep up when you're designing surveys. We talked about coverage and sampling error and so on, non-response errors. So those are very useful to remember. We talked about this idea of sampling with some confidence to get a probability sample. We talked about how you can go to great lengths to try to increase the response rate to your survey by offering all kinds of incentives or sending reminders or things like that. And we talked about this really cool social reward mechanism as one way to get people more excited to participate in your surveys. And this is sort of where we left off. So I want to continue today with a few more interesting, hopefully, bits about how to ask questions and whatnot. Okay, another very big, very common, very important to remember kind of bias that comes up in interviews and surveys is social desirability bias. Have you heard this term before? Okay, that's okay. What does it imply?
People want to look a certain way.
That's right. That's really the idea. Did you have something? Same? Did you have something?
Yeah, basically the same thing. People just don't want to exhibit behavior that is seen as like socially non-normative.
Right, socially undesirable. Right. That's exactly right. So that happens a lot. People want to make a good impression. For example, from a study, how often do you drive a car after drinking alcoholic beverages? Frequently, occasionally, seldom, never, or don't know. If you ask this question, it's a person asking you this question over the phone, 63% said never. If it's a self-administered survey that you fill out in the privacy of your whatever house or something, and you send it back afterwards without actually talking to a real person on the other end, 52% said never. So huge difference, right? And the samples here were both large enough for this to not be a statistical fluke. I'm skipping over that part. The point is, people tell you what you want to hear, and here you're seeing that effect. Right? People are less willing to admit to something that is socially undesirable. It's considered, it's frowned upon to drive while drinking. So they will not admit that they do that as often as they actually do when they can do this anonymously. Here's another cool one. How would you describe your current health? Excellent, good, fair, or poor? Fewer respondents chose excellent in self-administered surveys compared to interviews. Because you're less likely to admit to another human that, you're not doing well. Same as when people are asking you, how are you? Everybody always says, fine, how are you? Right? Very rarely does anybody say, oh, I'm terrible. Right? So it's kind of that idea. But it can really impact the data you collect through interviews or surveys. By the way, this is one example of many why I like looking at trace data that is not directly collected from humans that were knowingly participating in the study, because hopefully they are more honest that way. Here's another one. 20% of web survey respondents denied having ever received a D or an F in college, when in fact they had received one of those grades. Like presumably they would have remembered. So more likely that they just didn't want to admit to getting a failing grade. Another one still, very exciting, great gossip. Both men and women were more likely to report engaging in extramarital sex when interviewed by a same-sex interviewer than when interviewed by an opposite-sex interviewer. And this is an old study, so it's only binary here, but the overall point holds. People are less likely to admit to doing something considered socially undesirable. And you can see lots of instances of that throughout these couple of slides. Okay, related is this notion of acquiescence. Does anybody know this term?
You're like doing something that you might not have done otherwise if it's not for someone like implicitly asking.
Yeah, kind of being agreeable, I guess, or overly agreeable or something.
Yeah,
is how I think of it. Yep. Right. So this is a related kind of bias. The tendency of people to agree with someone rather than disagree, even when they, might want to disagree. But there's this tendency to avoid disagreement because disagreement is a form of conflict, and people are generally conflict adverse. You would rather avoid getting into a fight with others if you can, most of the time. Or fewer people enjoy fighting with, I don't know, strangers on the internet than the other way around. Okay. So here's an example of how this might manifest. In a study from the 80s, 60% agreed with the statement, individuals are more to blame than social conditions for crime and lawlessness in this country. Okay. At the same time, if the researchers asked or rephrased the statement by saying social conditions are more to blame than individuals for crime and lawlessness in this country. So they've just flipped the two parts of this. The first one was individuals more to blame than social conditions. The second one is social conditions more to blame than individuals. And 57% of people agreed with the exact reverse statement here. Okay.
Is this the same as the yours better effect? Like when you present people with two options, and if they know that one of them is yours, still like yours better?
Quite likely. Yes, either one of these makes sense to me. It seems both socially desirable to like your option, as well as acquiescent. Okay. So you can hopefully see that this both can be true at the same time. And the fact that this adds up to more than 100% is indication that people are being overly agreeable. Make sense?
through this slide. Well,
This one or before?
the next. So the percentages are only different by 3%. Is that I'm sure there are more complications to how they connected it.
So I think the idea is not 57 versus 60, but 57 plus 60 is a lot more than 100.
So there's overlap.
So there's overlap between these two. So, and there shouldn't, because they're exact opposites, right? If you agree with one, you have to disagree with the other necessarily, by the way they're phrased. Okay. Okay, so these were two. We talked about social desirability and we talked about acquiescence. Here's another one. Primacy and recency, these usually go together. The tendency to more frequently choose from either the earliest items in a list of options or the latest items in a list of options, regardless of their content. Okay. And there's this nice, I guess, model that tries to argue how they sort of play out differently depending on how you administer the survey and which items are more plausible and whatnot. It gets a little more complicated, but the point still holds that the order in which things are presented influences your choices. Okay, so I'll give you some examples. One way in which this manifests is anchoring. Anchoring occurs when an early response option acts as an anchor for comparison for later response options. You see this a lot in game shows on TV, by the way, if you're into that sort of thing. Here is one example. Which food is more typically German? Do you have any Germans in the room? Sadly. Potatoes and rice, if presented in that order, 30% of respondents say potatoes. If instead presented as rice and potatoes, then 48% say potatoes in comparison. Isn't that interesting? Wild.
Why would someone say that rice is more German than potatoes?
Because of either recency or what's the other one? Primacy. Yeah, because of that. Yep.
That from the same sample. You did the study twice with the same sample.
I have not read the original study, or I don't remember the details. What I imagine happened is maybe randomly divide the sample in two and ask one group the first version and ask the second group the second version, and each half is large enough so that you have statistical confidence, and then you kind of see this effect.
It's just from the order and not other factors influence.
Ideally, yeah, but go check the original study to confirm this. Yeah, if I would do it, that's how I would do it.
Can you elaborate on why they suppose they saw this effect or what increase is? I'm not sure I understand what the standard of comparison part of this definition is.
Yeah, so potatoes acts as an anchor here because it's presented earlier, or rice in the second condition. And somehow this forces people to overestimate the likelihood of the thing that comes after it because they've been primed by the thing that came before it.
So is the argument in surveys or in interviews that later options will receive higher weight, or?
Right, so this is where it gets subtle, and I don't know that I can do it justice. It can be either or. It can be that either the later option is the one that gets overemphasized, or the earlier option, depending on the type of survey and whatnot, and which of this is more plausible. So there's some combination of factors that results in one or the other happening.
Okay. So you might want to order your survey questions based on what you think is more likely to be responded to.
There's a better idea.
Randomize it.
There you go. Fun.
Is there a theory of why, in some times, primacy shows up and other times recency shows up?
This is the attempt at that. At explaining why one shows up over the other. So it has to do with whether it's self-administered or interviewer administered. So whether you have, I don't know, whether somebody's forcing you to respond on the spot or you have time to think about it or something. And it also has to do with which is plausible and implausible. And somehow the combination of these two, these people argue, is what causes one or the other. This is one theory. There may be more. This is just one that I have seen.
Okay.
Weird, right? By the way, I have another good example. I don't know if I have it here, but I use this sometimes. If, so I ask you all to estimate how much homework for empirical methods is going to take, or how much I don't know, let's say we do some quantitative analysis of the FCE data. And I ask you all to estimate how many hours you expect you're going to have to spend doing this work. Okay, so I could do this in 3 ways. One, I could just ask you that without giving you any context, right? And you're going to give me a number. 2, I can say something like, I gave the same homework last year, and students last year spent about 10 hours working on this homework. How long do you think you're going to spend working on this homework? Okay. The third option is similar. I could say, I gave this homework last year as well. Students last year spent about 40 hours working on this homework. How long do you expect you'll spend working on this homework? Okay. So guess what will happen in the 3 conditions? It's exactly this thing, exactly anchoring, right? If I give you a lowball number, your number is going to be an underestimate. If I give you a high number, your number is going to be an overestimate, and otherwise you get something in the middle. So you're anchoring your response into whatever anchor I give you. Which is why it's very easy to get garbage data when you're, I don't know, interviewing or surveying people, because you can very easily bias their responses in this way.
Yeah, I actually took a class of human factors last year, and we actually did that anchoring exercise.
Love it.
And they just distributed like pages to all of us with the 2 conditions, and they actually just saw that example happening.
Great. Yeah.
Yeah, even sometimes with unrelated numbers. So
yeah.
Sometimes you are talking about other contexts that's not, for example, about the hours. But people will anchor their responses on that number, even if it's not related to the number of hours.
Right. Yeah. Correct. Yeah, great. So we're even more susceptible to being fooled than this. Okay, very good. So this was about anchoring. This, hopefully you're convinced that this is a problem, so be very careful with how you're asking questions. Okay, so now let's talk about questions. The different types of survey questions. You can ask open-ended questions that people fill out open-ended responses to. This is very much like an interview, except people type the responses. You can ask for concrete things, you know, how many years have you lived in Nebraska, and you want people to report only whole numbers and round up to, you know, years or something. You give them detailed instructions for what kind of numbers you want to get back. You can ask closed-ended ordinal questions. We've seen this a lot, Likert style questions. By the way, it's pronounced Likert, not Likert. Took me years to learn this. I eventually did, so now I'm telling you the same. The person's name is pronounced Likert, not Likert. Okay. Oh, I love this one. Body height reported by US men. Survey of 200,000 adult men in 2021. Ask the question, how tall are you without shoes? And this was the distribution of responses. What do you see?
A lot of responses for 5'11". They're hesitant.
There seems to be a biological tendency to gender the US gender preferences. Same one. It seems that humans are naturally fated to be a whole number.
You're joking. I think it's very good.
It's a similar behavior where, like, in China, if you're 179 centimeters,
Yeah.
then you will say you're 180.
That's right. That's right. So there should be more 5'11" people and fewer 6' people, because this over such a huge sample, this is going to be a very smooth bell curve. And people are just lying, right? They're reporting reporting being taller than they are because they're close enough and they round up. Okay? By the way, if you're online dating, that's what happens too. Okay. Closed-ended, partially closed-ended. You can ask people to tick, choose multiple options, or select one. Okay, here is an example where you have to put some thought into how you ask the question. We've seen this time and again with interview questions. We've seen it with research questions. It's more of the same, really. So here, 3 ways of asking the same question. But arguably, the first one was very vague. How many times did you eat together as a family last week? Please fill out the number of meals. That's the first one at the top. Okay. And arguably, this is a vague way of asking a question because lots of things are assumed or implied here. What does as a family mean? What does together mean? What counts, what doesn't count? Very vague way of asking a question. So slightly better, with more specific and concrete concepts, way of asking a question is the second one in the middle there. How many meals did you eat together as a family at home last week? As opposed to how many times did you eat together? Because maybe snacks or something, aren't really what you're interested in. You're looking for a measure of, I don't know, family cohesion or something, people sitting down for dinner or something all together as a family. And it doesn't matter if they have snacks or not, and maybe it doesn't matter if they have breakfast or a granola bar on the way out to catch the bus in the morning or whatever else. They're really trying to capture something else here. The concept of interest is more specific and precise than that. Which is why the maybe best version of this is how many meals did you sit down and eat at home as a family last week? Right, so if you're grabbing something in the morning on your way out, the stereotypical American movie is, I don't know, the family's out having breakfast in the morning, and there's this giant spread that looks delicious, and then the kid comes down or something, walks by in a hurry, and then just leaves because they're late for school or whatever. And meanwhile, there's this delicious breakfast, they're just sitting, like, how can you, like, not, yeah, how can you just leave? It's like fresh orange juice. Okay, I'm getting hungry. All right. So a good point here, and we'll see more of this hands-on in a few minutes, is that it's really good practice to use previously validated scales whenever possible. What is a scale? Okay, we're going to talk about scales in a second. Okay, some guidelines for how to ask questions. Look at these when you're preparing to ask survey questions or interview questions. Okay, let me show you some more examples of how small changes in wording can have quite large effects. 3 ways of asking the same question here. Number 1, when did you begin your studies at Washington State University? Okay. When you ask it this way, only 13% of respondents give you the month and year. Maybe that's really what you're trying to capture. Okay. If instead you ask explicitly, what month and year did you begin your studies at Washington State University, which is the bottommost option, the third one, you get a lot better data, cleaner, less noisy data as a result of this. It's a very small change in wording, very big difference in the quality of the data you get back. Similarly, the one in the middle, sort of an improvement over the first version, but still quite ambiguous if you're trying to optimize for getting the month as well as the year. Okay, so what date is by itself not enough if you're looking for month and year.
Yeah, I'm wondering why, with people asking what month, still some people report CMU.
Yes, yeah, I know, I agree. Yeah. My guess is people read in a hurry, or they misread the question, right? Or they don't think too carefully about the question that they're answering when they're answering it. So my guess is just human error. Because at this point, it seems very clear what the question is to me. So Seems like they should know what to answer. But in any case, it's still pretty good, you know, compared to the original version of the question. All right.
Is this a question that might benefit from having standardized values that you could input so that the 11% disappears?
Yeah, you could do this, I guess. You could have a drop down or something. Or a date picker or something like that, if you do this electronically. Yep, that makes sense.
What did the other people answer?
I don't know. Good question. Source is there. It's in the shared drive folder. You can go read.
So these don't add up like same. They don't add. Is it like more answer?
Oh, great point. Yeah, great point. I don't know.
Yeah, that's what I assume.
Answer it more.
Right. Other kinds of responses. You mean horizontally, right? Is that what you're saying?
Yeah.
Horizontally, they don't add up to 100. Right. So maybe there's other columns here. But I guess these were the dominant ones, the prevalent ones. Right. Okay. Here's an example of prompting. In your own words, how would you describe your PhD advisor? Versus, this question is very important to understanding the Washington State University student experience. Please take your time answering it. And then you ask, in your own words, how would you describe your PhD advisor? So just a prefix that puts more emphasis on that question. Do I have numbers? I don't have the numbers. There were numbers somewhere. Gets you a lot more responses to this question.
Here's like how we should judge.
Yes. Yeah. So basically, there's nothing new in prompt engineering. It's all we're doing all these things to get more information out of humans too. Yeah. Now we're tricking the machine to do the same. So obviously you can't do this with every question in your interview or in your survey, because then, you know, none of them is important anymore. They're all very important. But if there are some that are really important, this is a very easy way to, you know, make sure people answer them.
Do you know if it has like a lukewarm effect on every question if you preface the entire survey with like this survey is important to us or something?
I think you should do that. I think if you look at the letters that I gave you as examples of this whatever mail-based survey that I talked about last time, they had all kinds of language like this about the importance of the study and so on, and asking for help from the respondents. I don't have numbers on effect sizes, but it seems like it's a useful thing to do.
When I was doing some surveys, on the first page, they always talk about how important this is, but I usually don't read those. I go straight to the questions and then read the questions. I don't actually read the information in front of before the survey actually begins. So that might be. I feel like some people do
I
this.
feel like the IRB would be mad if you tried to pull specific text that you want people to read over the consistent information.
I mean, you put it up there, but people might not actually read it.
Yeah,
That's the thing. Like I didn't read a lot, so
I never read it either, but the way I would get around that would be like by highlighting some specific text that I want people to read, but then the IRB would be mad probably.
There's a lot of variance in how people process information. So there will be people that read very carefully instructions before answering. In the same way that you don't read maybe any before answering. Come on.
Oh, I was gonna say you could like just say every single question is important, but like make it more and more severe each time. Use like one text or
I love how you're thinking. Long.
I wonder how much this has changed, like say, if we did this like 40 years ago now, because the internet with things like license agreements, like
Yeah.
they go on the recipe website and there's a huge text before you
Yeah.
get the recipe. So like I noticed, like say people like my grandparents' generation, they actually read more of the text because they're not used to that all that wall of text on the internet. So it's as much. Like,
Right.
But like us, like younger folks, just skip over it.
Well, you all, not me, but yes. I agree. I think think a lot of this needs to be revisited for the modern times. I imagine people are doing this kind of research. It's just far enough removed from the stuff I read on a day-to-day basis that I don't see it, but I imagine there must be new stuff revisiting some of these old assumptions and effects, yeah, for modern times. Okay, very good. Okay, here more on probing again. This also applies to interviews. What businesses would you most like to see in the neighborhood that are currently not available? And so you ask this question by itself to half your sample, and randomly to the other half, you ask the follow-up probe, are there any others? Presumably people tell you something when you ask this the first time around, and then you follow up with a probe saying, are there any others? A very simple thing to do. Guess what happens? You get a lot more data. So quite a big difference there. And almost one extra business on average difference between the two groups. Okay, you can very easily do this in interviews, variations of this, or in surveys.
Surveys doesn't make sense.
You-
Because you're asking the same thing twice. So if I was answering, I would like, well, I've written everything above, so I don't care.
Well, so the theory here is that, if I ask you the same question essentially again, can you think of another example after the previous question? On average, like people will fill stuff in.
I see that working in interviews, but it seems weird in surveys.
Try it and tell me. Randomly divide up your sample. See how many more answers you get. Okay, here more again on probing. The type of probe will impact the amount and the type of information you receive. Question is, in your own words, how would you describe your PhD advisor? And then the probes are, is there anything else? Kind of like in the previous example. And 18% of the people said something else, and most said no. Right? When asked this way, is there anything else? Then, if instead you ask, can you tell me more about that? 82% responded with additional information, including new ideas or themes, as well as elaborating on previously reported things. So look how subtle a difference, right? The question here implies a yes or no answer, right? And people want to get out easy, so they just say, well, no, and that's fine, right? Here, they were forcing them to tell you something, and they do. And apparently they also tell you something useful. So it's not that they just make something up. Right, so very small difference, very big impact, arguably. Okay, here is an example where acquiescence may occur. Do you favor congressional term limits of 4 years? Question mark. And then answer options are favor or oppose. Or similarly, how satisfied are you with the overall service you have received from your financial consultant? Very satisfied to very dissatisfied. Why are these bad? Somebody we haven't heard from yet today. Yes, please.
The wording in the question suggests one of the answers.
Right.
They use favor in the question, and it's with the responses as well.
Right, so you're expected to be biased towards favoring or towards being satisfied, right? That's the idea. And it is true. Do I have numbers? I don't know if I have numbers. Here's a way to improve the design. I don't know if I have numbers on the slide for differences in scores. So do you favor or oppose? We talked about this when we talked about this, asking research questions. We already talked about this in the beginning, or how satisfied or dissatisfied, bipolar phrasing rather than kind of leading. Hi.
Can that be privacy or recency within one sentence? Like if I place favor in front of oppose, Or like, would the answers change if I said, do you oppose or favor congressional term limits of 4 years?
Yeah, great question. I haven't seen the evidence for that. Which isn't to say that it cannot, I just don't know. Right. I've seen more often people fiddling with the answer options. I don't know how much the order of the terms in the question would make a difference.
There's also, so when it comes to survey design, this implies that the person who's filling out the survey has an opinion, because you have to give an opinion. Is it better to structure something like that and possibly get false data where you're forcing them to give an opinion or to give them?
Great point. Yeah, great point. I agree with this. I don't know. Obviously, it's not good to get garbage data ever. So somehow you should figure out a way to filter to make sure that people have an opinion when they give you answers to these questions.
Materials will also a neutral option.
This is a big trade-off. For the reasons you mentioned, right? If you offer a neutral option in questions, and often, right, with these kinds of Likert satisfaction style questions, you often see a middle point. There's a big debate around this. The middle point is the easy way out, right? Because people, don't have to take a strong stance on the issue, and they can just, be neutral and, move on with their day. And so the advice is often to remove the midpoint, right? To actually force people to have an opinion, because most often they just choose the middle, and that's not useful at all. You can't learn anything useful from that. But at the same time, you risk forcing them to have an opinion they don't actually have. So I don't know that this is settled. I think it's very much still a debate for how to do this. But it is certainly a trade-off. Like, you should be aware of this when you're doing this. Like, the midpoint will bias people towards being neutral, even when they have opinions. And the lack of midpoint will, obviously force an opinion, also when people don't have one.
Do you have any suggestions?
I don't have any suggestions, except you're in trouble. My personal preference is to force an opinion, but that is very subjective. I don't have the science to justify that. Yes.
If you force an opinion, then people who do not have the opinion, like their opinion, their forced opinion should theoretically cancel out, right? Like, maybe half of them will go to someone satisfied, half of them will go to someone dissatisfied. Or could there be this bias? That bias is the forced opinion of the neutral people to be neutral respondents to be one of the four options.
Very likely, because of the types of biases we saw earlier, like acquiescence and social desirability and so on.
That doesn't happen for the favor or oppose, though. Like, there would be no balancing out there. Do you have no way to tell if they're kind of but you would be able to see if maybe with this somewhat.
Yeah, I guess it also depends on what the question is, or how pronounced these biases may be. Right?
So Likert questions are basically ubiquitous in surveys.
Correct.
Right? Yeah. I was wondering about different kinds of questions which sort of get at the same thing, because recently in another class I was learning about the difference between valence and arousal. Like, people might be neutral, but actually they have very strong positive and very strong negative associations with things. Is there some kind of four-dimensional kind of test for that, or is there anything similar to the Likert style questions that people do?
We're going to talk about scales in a minute, consisting of multiple items and multiple questions trying to get at a certain concept. So that's where I think I can answer some of your questions. By the way, another point for in this debate for a midpoint, think of program committee paper reviews for research papers. This tendency of people to be neutral very much shows up there as well. People will be sort of borderline if you give them the option on papers that they don't have strong, they don't hate them or they don't absolutely love them. They'll be borderline. And it's very hard to, arrive at a consensus decision when you give people that option, because everybody will just be borderline and, you won't know what to do as a program committee chair or something with that paper. Like sort of stalemate. You're stuck, right? So much better to just force people to take a stance either towards accepting or rejecting the paper. At least insofar as reaching a conclusion is. I don't know if it's a good outcome for the paper necessarily, but at least it kind of pushes the process forward. Yeah.
We say we're forcing someone, but they could just not answer the question. Would you just throw out the entire survey if they refuse to answer a question?
I mean, that's your decision, right? How you treat missing data is a analysis decision that you, the researcher, has to make in that given context. But what is appropriate and what is not appropriate is something you have to decide.
You don't answer this, we're gonna throw out. Yeah.
So think of non-response bias we talked about last time. Right? How different fundamentally are the people that didn't respond to the survey in the first place from the ones that ended up responding? And in what way does that bias your conclusions? It's the same thing here, right? What is it, why did these people refuse to answer the question? Is it because they have some sort of, very different view or something of that issue that you're excluding by, excluding their missing answers? So it's sort of useful to think about this decision in terms of kind of non-response bias. How would it, why is it missing? How would it change your conclusions?
Probably in most scenarios, I would assume it's because there's no neutral answer, but it's probably scenario dependent.
I mean, yeah, I suppose they could, they could be somewhat satisfied, right? If, they're being agreeable, right? They don't have strong feelings. There's no neutral. They're probably somewhat satisfied. Right. My guess. Yeah.
You tell them to try to avoid picking the neutral option in a similar way as like how you said, like this question is very important to us.
Sure, but would Leo read the instructions?
Read it at least once.
I think in general, yes, you could give them instructions. There's a risk that people just won't read them, or misinterpret them or whatever. But yeah, I think more clear instructions is generally a good idea. Don't make the survey instrument too long. Don't make it too hard to complete the survey, right? Don't make them read too much if you can avoid it. Is a trade-off. But certainly clarity is useful. Yeah. All right, very good. All right, yeah, this is cool. Primacy or primacy shows how the order of items changes the outcome quite drastically. So here you're asking, which of the following resources have you used as a student at Washington State? Please check all that apply. Note how in the example on the left, libraries is the topmost option, and library instruction is somewhere near the bottom. I guess you go to the library and you take courses or something. I don't exactly know what this means. They may know. Library instruction. The librarians teach you something useful, presumably. Okay. I don't exactly know what this means. But in any case, note how when presented this way, very few people have the patience to keep checking boxes by the time they get to the end. And you get very little representation on this item. Whereas if you change the order, right, now library instruction is close to the top, then a lot of people click and select this option. And interestingly, this doesn't really decrease all that much the representation, the representativeness of libraries itself.
maybe because it's also in the end. Then you have the other effect.
Maybe because it stands out as being very common, so it's something that, doesn't matter where you put it because it's so obvious that people will select it anyway. But maybe the more subtle things get overlooked the farther down they're buried in the list of options. That's my interpretation here.
But can't you have what's the other one? It's not parentheses.
Recency.
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 Like if you have it by the end.
Right, but we're not seeing that for libraries because it's sort of about the same in both cases.
But I'm not talking about this.
Right, yes, you can have that both ways, yes.
Because if I'm imagining people reading the survey, read the first options, okay, so mine, okay, let's like read the last one.
Right, which is why, again, coming back to the point earlier, the best strategy here is to what? Randomize the list.
But for each participant.
For each participant, correct. Yeah.
Oh, so maybe people don't know what library structure is, because I looked it up, and it's something actually I had, but I didn't realize I had. It's basically learning how to use the Dewey Decimal or Library of Congress system, microfilm reader.
Cool.
All the tools in the library. So
yeah, so maybe a less charitable interpretation of this result here is that people just didn't know what it meant and they thought it meant library. So then more people selected it. Right? So that could be the case. I don't have enough information about what happened here.
Will this result change if you put the sentence please check all that apply in the front?
Good question. I don't have any evidence.
Because usually I will just read the question and ignore if it's a single choice or multiple choice.
Yeah, great question. So maybe for you it would have an effect. So I guess on average then probably also, right? Harrison.
Is this maybe related to anchoring as well?
Mm.
When you start going to the list, you see library instruction first, you sort of like, oh, these libraries. You haven't already seen libraries, you haven't taken that option out.
Right, yeah, right. So it could be multiple of these things happening at the same time, right? Resulting in this. Agreed. Okay. Which of the following items do you have? Please check all that apply. Desktop, laptop, cell phone, e-reader, tablet, iPod, or MP3 player. Yes, okay. So this is the same point. If this please check all that apply style question will on average give you fewer responses back. Like people will start reading from top to bottom and they will check a few things and they will decide that they've checked enough things and they won't read the rest of the list. They will feel good that they've answered this and they won't really care that they haven't read all of them. So that will happen. A better design is to force an answer on each of the items. Right, so here they have to select yes or no, literally for every one of these items. And so this is better in terms of ensuring maybe that you get more data. It's worse in that it makes the survey harder to answer. So it's likely that more people will just drop off, right? They'll get to this point and they'll look at the question and they'll be like, yeah, this is too much work. I'm not going to bother, and they'll just drop off. Right, so this is always the trade-off. The harder you make the survey to answer, which happens to also help with data quality, right? A lot of the times, the more people will drop out, and that's not useful. So there is no silver bullet here. Sort of, you have to like walk this fine line between data quality and ease of filling out the survey. The same for an interview, right? If it takes hours, right? Very few people will have the patience to sit through hours of being interviewed. Just exhausting. Same here. Okay, Likert scales, pronounced Likert. Right, looks like this. So, right, so we call each question, we call that an item, and we call the whole thing a scale. I was asking you earlier, what's a scale? A scale is a collection of items, questions, if you will. They're usually phrased in this strongly agree to strongly disagree or similar. Okay. Yeah, so this is where it gets interesting. So now, why do I mention scales? Let's go back to this for a second. Okay. So why do I mention scales? We talked basically 2 days now about how, and interviews also, about how small changes in the way you phrase your questions can have maybe outsized effects on the answers you're getting. And it's sort of very hard to figure out how exactly to ask the question in the perfect way. So people have essentially worked around this problem by asking all kinds of questions in all kinds of ways that all try to capture the same concept. So that, whatever noise and so on impacts one of the, and so the answers to one of the questions averages out with the noise, hopefully in different directions that impacts the answers to some of the other questions that are trying to get at the same concept. So you often see that the better surveys have these multi-item scales trying to capture the same concept. Basically, lots of questions asking you essentially the same thing in different ways. We're going to look at how they have validated that indeed those questions capture the same concept in a minute in our when we're doing factor analysis. So let me give you we talked about this midpoint dilemma. There's more here. Okay, yeah, let me give you an example. I'm skipping over a few things there. This is a questionnaire that was given, I can move the window, that was given to 7th graders in the Netherlands to capture their pleasure in writing. And these are all of the questions that were asked on the questionnaire. We're trying to capture pleasure in writing. And note a few interesting things. One interesting thing, the same question asked in the positive and negative. I love writing, I hate writing. Right, so for somebody that loves writing, you'd expect them to strongly agree with the first one and to strongly disagree with the second one, and vice versa. Okay, so it's a way to maybe see if people are paying attention and they're reading the questions carefully and so on. Notice also all kinds of questions that basically ask the same thing. Writing is my favorite school subject. Writing gives me pleasure. Or, and the opposite, writing is boring, or I write because I have to at school. It doesn't give me pleasure. It's not fun. I do it because I have to. Okay? So the same thing, you're asking the same thing in slightly different ways, okay, including in the opposite, and so on. So now, what you do then, so how do you arrive at this? Let's say you brainstorm all of these ways of asking this question, or you ask ChatGPT or something. Presumably it would be good at doing something like this. Okay. How do you make sense of all of this data, and how do you figure out if the scale is valid? What does it mean for it to be valid? Well, it means, for example, to get consistent results, right? So, for example, if somebody who loves writing strongly agrees with the first question, you would expect them to strongly disagree with the question that's raised in the reverse, and so on, right? You expect this kind of consistency, and you expect, somebody who strongly agrees that writing is their favorite school subject at school to also strongly agree that writing gives them pleasure and writing is not boring, right? The opposite of that, and so on and so forth, right? You expect that the answers are consistent across these different ways of asking the same thing. Right. So here's where this idea of factor analysis comes in. So basically, there's some latent, unobservable, some latent factor. This factor is maybe, I don't know, love of writing. Right? There's some latent, unobservable factor that causes all of these answers on all of these questions, is the theory. right? The latent unobservable thing is love of writing. You can't measure that directly, but you can ask a bunch of these questions. And, people who really love writing will answer consistently on, all of these questions, right? And people who really hate writing will answer, consistently in the negative on all these questions, and so on and so forth, right? So this idea of factor analysis is to discover this latent factor and see that the answers to these different questions load consistently onto that latent factor. Okay. So here, right. So this is an example of how, let's say there were two. There's basically some decomposition of this data in the two-dimensional space, and there's some maybe two underlying factors and right that you're trying to uncover. I want to look at this hands-on in a second. This has to do with how many factors are there and how you decide to if there's 2 or 3 or 20. I'm going to show you this directly in R in a minute. This is what the result of this factor analysis may look like. So here you're trying to estimate 2 latent factors on this data that I've showed you. You have concluded that maybe there are 2 latent factors, right? Maybe you know that going in based on how you ask the questions. Maybe you've concluded that empirically based on this analysis I skipped over. And you're trying to see how much do the different answers to the different questions load onto your 2 factors, right? The higher these loadings, the more that factor is said to, cause those answers to that question, and the more consistent those questions will be. Okay, so here's an example of what this looks like specifically. So if we look at the first factor here, and this is a value, think of this as a correlation, if you will. This is a value between 0 and 1, essentially, or -1 and 1. The closer to 1 in the absolute sense, the better. Right, the stronger that correlation is, the lower the value, the closer to 0, the worse that correlation is. So if you look at all of the questions and their loadings onto this first factor, you can see that the ones loading highly onto this factor, 0.5, 0.7, 0.6 correlation, and so on, are the ones that I highlighted in yellow there. And you can see how they're all very consistent. They all capture the same concept, really. That makes sense? Right. So the idea is to validate that, the many, in this case, 20 questions capture, one or few underlying constructs, right? There's probably not 20 underlying constructs. You're asking the same question in 20 different ways because you're trying to really capture this one or few underlying constructs. So the factors would ideally represent these underlying constructs, right? They are latent, they're not observable, they're sort of, inferred, right? They're latent. But based on the questions that load most highly onto those factors, the ones that are most strongly associated with those factors, you can decide to interpret them and name them. Okay? So, the question is, how many of these factors do you assume there are, right? So, there could be as many as the number of variables. There could be up to 20, right? And it could be as little as 1. It could be that all of the questions load very highly onto the one factor, or it could be that they all capture very different things, and you end up with 20 different factors, right? Neither of these is, I guess, one may be useful, the one with 20 is absolutely not useful. So like you want to have, typically few latent factors. Because this is a way to validate that these questions are capturing the same phenomenon, the same construct. Right? If they are not, right, 1 second. If they are not, right, let's say you brainstormed these different ways of asking the same question that you thought these were all going to be the same question, but you're finding out that one of the questions gives you very inconsistent, very does not load at all, does not correlate at all, or the answers to one question do not correlate at all with the answers to the other questions. Even though you designed it to be that, right? That is an indication that maybe people misinterpreted the question. Right? You thought they were going to answer it in this way, turns out they did not. So that would tell you that maybe that's a question you should remove from your scale and simplify your scale.
And you find that by saying if the questions are going on the same direction.
That's right.
Positive, negative.
That's right. And on which of these, so the expectation is that the questions that are capturing the same concept would all load onto the same factor, and furthermore, they would load strongly onto the same factor. Come on.
So just like a question, so the numbers in the factor column are representing correlation with all other, with the rest of the respondents in the group. So like for 9, it's like, it says like 0.702, is that correlation with the rest of the column, or what is that for?
This is how much of this question is captured by this factor.
Okay.
Essentially.
I see.
How, right, how.
Like how much of how much of the underlying concept represented by the factor was essential to answering that question, or like played a role in it?
How much of the variance in the answers to question 9 does this one factor capture by itself?
Okay, yeah.
Right.
I definitely don't understand the math now, but hopefully we'll be able to do that in the hands-on part. And maybe you'll talk about this later in the presentation, but I was wondering, like, this seems like something that you do after you have a few preliminary answers to see how you can revise your questions and make sure that they're all asking the same thing.
Correct.
But are there good guidelines for like how to construct a question that is like a synonym of another one without it being like detected, or like how to do this well in advance so you don't have to revise it all that much?
Probably. I don't have anything at hand. You will see 2 strategies here that are common. I think one is this reverse coding. Right, so asking the same thing in the opposite, in reverse, that's very common. And the other is just, variations that are superficial variations, lexical variations on the same question. And I don't have a process for generating these. There must be one though, or I guess an LLM could help, or just brainstorming. And then you run a pilot survey, you have some responses back, and you see to what extent these make sense. And you keep the ones that make sense, and then you drop the ones that don't make sense or rephrase them.
Yeah, about the like valence versus a relevant thing. Like this is definitely something that would be easier to tease apart in an interview, and maybe you would just throw out participants who contradict themselves. But it may be possible that they hate writing in some contexts and they love writing in other contexts. Like, I don't know, is that something that you would want to capture in a survey, or is that something that you would want to throw away?
I don't know that I can answer this. I think you want to capture in the survey whatever data you need to answer your research question. So it will depend on what the goal of the study is and how much this variation in context and so on matters, or it's kind of a central part of the study versus the distraction. But I don't know.
But would you normally, like, assuming you've isolated these factors in your mind, like what you're looking for, would you normally throw away data points that frequently contradict themselves on these questions?
Probably. Right. So I guess in terms of the process, if I was confident that the scale is valid, right, that the questions are, valid and they're meant to capture the same concept and so on, after going through a process like this, then if I got inconsistent answers, that would probably be an indication of people, I don't know, not answering seriously or something. It could be a justification for removing them. With things like Amazon Answer, you often see these attention style questions or tasks or whatever that are kind of interspersed with the actual thing you care about, just to see if people are actually doing the thing, or I don't know, automated or something.
Yeah, actually thinking.
Right.
Makes sense.
Yes.
Should we be, I'm looking at factor, sorry, not factor, P1, which has a pretty positive or, actually, I don't know what to say, number for factor 1. But it's a little bit weaker in the negative direction for factor 2. Should we be concerned that it's not higher magnitude?
Okay, good point. All right, so good point. So all of this, we're getting into this realm now of, I don't know, data interpretation, especially exploratory things like this. This is called exploratory factor analysis. All of this is very much still an art, has a lot of science behind it, but it's very much still an art. So part of the art here are things like, well, you know, some things will be so low correlations that the software itself just doesn't print them. Others will be subjectively low, and you will decide as the expert that you're ignoring them. For example, this 0.13 thing is for sure something that's comfortably ignorable. Right? The 0.46 thing is kind of getting substantial, right, in terms of correlation. So I don't know what you do with this. But this is kind of where some of the art comes in. Then more of the art is, you know, ideally, like I told you about how you have to decide how many factors you're looking for. And obviously there's at least one, and there's at most however many variables there are, right? And usually lower is better, like, because you're trying to, you know, simplify, reduce the dimensionality of the data. You know, so you can see how this may get confusing, right? So the more of these factors you will have, the more it becomes possible that every question loads onto multiple factors or cross loads. So when you have that, I don't know, do we have a good example here? Well, maybe this to some extent. Maybe these two to some extent. So you have questions that will then end up loading substantially onto multiple factors, but that doesn't make sense, right? Because that means the question isn't capturing any of these concepts really, right? It's partially capturing all of the concepts. So to me, you know, as the analyst, that would be indication that this is not a very useful question to have in the survey in the first place. Right, so that's something where I would, you know, go back and say, you know, maybe this is a candidate for removal from the scale, right? Because it turns out that it loads highly onto multiple factors, and I don't know how to interpret that, right? It can't capture both, you know, love of writing and, you know, anxiety and whatever else that, you know, these things may end up being. Okay.
I wonder if you could, I don't know if this would be a good idea, but you can almost put like a control question that's independent of the factors and see, are your factors really independent? If it does, it should load pretty evenly.
Yeah, so I have, I guess we don't have a lot of time. I have prepared an example for you all to play with. So what I would suggest you do is, yeah, I'm going to get you started, and you can continue doing this at home. First off, in our lovely shared folder under surveys, there is a CSCS folder with a CSV file in it. This is a data set. It's a real data set that I stole from the Canadian Alliance for Social Connection and Health. They have an amazing survey with 11,000 participants over 3 years, and has all kinds of amazing data on how people felt during COVID and isolation and burnout and all kinds of things like that. Ton of questions, and the whole data set is public. So I've pulled I've pulled that. So yeah, let me make this a little bigger. Okay, very good. This is our studio. Welcome to R if you haven't used this before. Our studio is going to be great. Okay, so this is the data I just showed you. Okay. You can follow along if you'd like, or I can maybe walk you through a little bit of this. I guess we have 5 minutes, so let me walk you through a little bit of this, and then I'll share the file afterwards, and you can try this at home. Just because we won't have time to go through it from the beginning. So I'm loading the file, reading it in. Some issues there. You can see that there's thousands of entries. You can see sort of what the names of the columns are. There's a long list. So these capture all of the different answers to all the different questions they had on the survey. A long list of things. I'm not going to look at all of this. I pulled out. Yeah, keep scrolling. Right. I pulled out questions that have to do with burnout specifically, and they had some scale called the Malak-Pine scale for measuring burnout. Apparently, this is some validated instrument for measuring burnout. I didn't look more into it. Anyway, I pulled those columns from this giant data set, and this looks something like this. So every row is a response, every column is a question, and I've only pulled those questions about burnout. You know, tired, how often do you feel tired? How often do you feel disappointed, hopeless, trapped, helpless, and so on? There's a few of these. Okay, difficulty sleeping, and head burnout. Okay, so that's the scale, right? Then I convert this to numbers because I can't do this kind of factor analysis on string labels, right? So always gets a 7, very often gets a 6, and so on. I just assign numbers to these categories, convert them all to numbers. All right. So here I'm doing 2 things. One is I am adding a random column just to show you what happens, okay, which is literally a randomly sampled value on this scale from 1 to 7, okay, as if somebody had answered that. And I create this fake new column to add to the data frame. Okay, so I've done that. And then it looks like this, right? So it has all the same questions we had before, except they're numbers now. And it has this last question that is randomly generated that looks the same, right? Okay. One more thing I've done here is I have created a slightly less random, but still fake column. I call this less depressed. So I take all the values from the depressed column, copy all of those, and I subtract 1. So I just make them slightly less depressed. Okay. And then I remove the zeros because I don't know, you can't have zeros. So I overestimate the ones. Okay. Just to see what this would look like. Okay, so imagine, you know, there was another question and the answer to the check. All right. So that's the distribution of answers to that question. Okay, so now you could do, let me skip over the alpha thing, although that's also interesting. I'll come back to this in a second. Right, so now you could do, do we have one? Yeah, this guy. Okay, so this is the magic plot I showed you earlier. Right, so we're trying to decide how many factors there are in this data, right? So, intuitively, the random column I created, that surely cannot possibly correlate with anything because it was randomly generated. So that by itself should probably get its own factor, right? Then there should be some number of factors from the actual validated burnout scale, right? Maybe a couple, right? If you look at the questions again, If you look at the questions again, some of them have to do with physical manifestations like difficulty sleeping and whatnot. Some of them have to do with feelings of hopelessness and so on. So you can expect, that there's maybe a couple of different factors in the actual burnout scale itself. So, there should be a few factors probably in this data, right? So this plot, so we're looking at the factor analysis version of this, the actual data. So this tells you, as you're increasing the number of factors, obviously they become less meaningful, right? They become harder to distinguish from, random, from noise, right? That's hopefully intuitive. So you can see that, and this is the way of visualizing this, right? So with one factor, you can sort of see how much variance that one factor captures. There's this magic math here happening with, eigenvalues greater than one versus not. Anyway, so certainly at least one factor, and you can sort of see where this starts trailing off. The dashed lines here represent kind of random chance, basically. So the point of inflection in this street plot is where you stop being able to distinguish factors from noise, random noise. And that's indication that you should stop there or earlier. Okay, so you're looking at the blue triangle data, which is our factor analysis data. You can see 1, 2, 3, maybe 4-ish, right? And after which it starts becoming noise, and certainly not beyond that. But you can argue that, maybe 3, maybe 4, that makes sense, right? At least a couple, right? So certainly these are meaningful. They're substantially different from noise, the first couple, and then they kind of get decreasingly meaningful after that. All right. So now you've decided that. So there's, between 1 and 4 factors, say, based on this analysis. So you go look at them. Here's what this looks like. So I'm doing factor analysis with one factor, assuming everything loads into one factor. That's a stretch. Certainly that probably won't work, but it's a sensible thing to try. Okay, so then you get a few things back. Uniqueness is a measure of how much of that variable is not captured by the underlying factors. What's left? So you want uniqueness to be low, right? You want most of the variance in the variables to be captured by those factors. Okay, so if you see high values of uniqueness, it's probably a sign that you need more factors, or you're not capturing enough of it. And that's what you see here. If you look at all of these, they're pretty high, right? The maximum value is 1, pretty high values of uniqueness. But certainly one factor is not enough, and that's kind of evidence for that. If you look at the loadings, it tells you how much do the variables load onto the one factor, and they all load very highly onto the one factor. Of course they do, right? They have to, because it's just one factor. There's nowhere else for them to load than that one factor. Except the random one, which makes sense that it wouldn't load at all onto the one factor because it was just noise. The random one is not meaningful in any way by construction, but that's how I created it, right? And all of them load highly onto that one. Okay. Then you could look at how much variance does the one factor explain about 43% of the overall variance in the raw data is explained by the one factor. Right, so you still have more than half of the overall variance unexplained, which is another indication that you need more factors. Okay, but the scree plot already told you that you need more factors. Okay. All right, so that's sort of this. So now let's say we do 2. Okay. Well, we can look at 3. Here's one with 3. Yeah. So 3 factors, much lower uniqueness overall, right? You can see this here. Yes, Ian?
Is the number of factors the number of variables in the regression analysis?
The number of factors the number of variables in the regression analysis?
In a regression analysis, that's what's going on?
No,
No.
no, not at all, actually. The number of factors is
This is the dimension of using
Mhm.
smaller dimension.
That doesn't make a difference than reduction or regression.
Oh, that's different.
I have never taken the
so these are your variables, the things you measured, the answers to the survey questions. Okay. And there's some latent unobserved factor, one represented here in this diagram, 4 variables, 1 latent factor. You can't measure this thing directly, but this thing is causing people to respond the way they are, on these questions. Right? And if all of these 4 variables load highly onto this one factor, it means that one latent factor captures, this concept that all of these 4 variables represent, and that they are consistent, consistently capturing that one underlying factor. So the goal of this analysis here is to estimate, to find these underlying factors that you can't measure directly as a way to see how consistent these things are.
So this is principal analysis.
That's a great question. It's very close to that. Principal component analysis is this. Principal component analysis is just a linear combination of the variables that you measure directly with the survey. Right, so it's literally this, like you're estimating this linear combination that captures most of the variance. So it's very similar, but sort of fundamentally also very different, right? There's no latent factor that's unobserved that causes these measurements. But rather, you're grouping these measurements, you're creating this artificial linear combination of these measurements as a principal component. Right, that tries to capture as much variance as possible. They're very closely related, but somehow different at the same time. For the purpose of validating a survey scale, the factor analysis one seems to me more appropriate, kind of conceptually. You're trying to,
Something that you don't.
right, because you can measure this thing directly, right? You have all of these proxies that are each imperfect in some way, right? And you kind of have multiple dimensions that all together try to capture this hard to measure unobservable construct. And you're trying to see how well do they actually do that. So I think sort of theoretically, this factor analysis framing of this makes more sense for survey design, but they're very similar. Also in practice, they're very similar. It's basically the same thing in R also.
Right, so you're just giving the number of factors. You're not like, it looks like right, you're saying factors is 3, you're not giving it.
Yeah, I'm giving the number of factors and I'm telling it whether to rotate this or not. So I gave you that example of this 2-dimensional space, right? So you have maybe 2 factors there. Depending on whether you are strict about those being orthogonal, or whether you allow that they are correlated to some degree, right? That changes a little bit, the
Parameters tells you that?
The rotation parameter tells you this. So essentially, do you enforce that the factors be orthogonal? meaning uncorrelated, right? So, factor 1 and factor 2 and factor 3, you ask that they be orthogonal.
What is variance? Is that orthogonal? Is that?
That's orthogonal.
That's orthogonal.
Or you allow that they be correlated to some degree, they overlap to some degree. And then there's a different parameter for that.
Are we gonna learn about how you get these numbers? Because I'm just.
You can read about how this is estimated on your own. I won't be able to, I won't have time
Okay.
to teach a class on algebra. You can read about all of the estimation here. I'm more interested in how you apply this and how you interpret this than how the estimation works. But I pointed you to reading materials in my shirt folder for the algebra behind this. Harrison.
When you're taking survey questions and breaking the numbers, how important is it to figure out the right way to do that?
Yeah.
You did it in sort of a clear way, but is that factors?
Yes, a lot. Right. That's a great question. You have to be careful when you do this, right? Does 1 unit increase in this numeric scale correspond to 1 unit increase? Is that equidistant? Is 1 unit the same between all the categorical variables? Because it is the same between the numerical variables. So you have to be careful when you do this. Yes. Yeah, so it matters. That's the short answer. Okay. The last thing I want to show you here is I've shown you that 3 factors is better than 1 because they are less unique, right? They load more onto the factors. You can see also the loadings a little bit. So you can see kind of some factors load highly, some load lowly. The random one obviously doesn't load at all as it should. Right, so something like this, high loading on factor 1, low on the other ones, I would ignore these and just say, this variable is captured by factor 1. And I don't care about the little variance left there, and so on and so forth. Ideally, there's nothing where this is a little ugly, right? So there's a lot of variance in both factors, and maybe this is a candidate for, revisiting, or maybe I need fewer factors or more factors or something. I need to redo this, but this is the one unsatisfying, right? Because it loads relatively highly on 2 factors. Something like this, or like this, much easier to ignore, right? I can focus on the bulk of the variance and ignore the other ones. Finally, you can see how each of these factors captured some substantial amount of variance. Jointly between the 3 of them, we're now at 60% of the variance in the original data between these 3 factors combined. And you can see sort of how that accumulates. And yeah, that's sort of how you think about this. Things that.
Do you try to name those factors?
Yes, absolutely. Yeah. So that's where the more of the art comes in. You look at the loadings and you look at the ones that load highly. You filter out the ones that don't load highly, you see what's left, and then you look at what's common between those things that load highly onto factor 1, and you do a thematic analysis basically on these, and you're like, oh yeah, that looks like physical manifestations of burnout. Or like, oh yeah, that looks like emotional or whatever, state of mind things, or whatever else. Okay? And they should make sense. But if they don't make sense when you interpret them as a human, then probably something wrong happens as part of this, right? You should be able to interpret the factors if the survey instrument was well designed, because otherwise it kind of doesn't make a lot of sense. Okay, so how about this? I share this as an example. And then I ask you to do one of your own. I have the GitHub open source survey. So this thing. I have the open source survey.